Welcome back. In this video, I'll be looking at 2.1 set notation. 2.1 represents Chapter 2, Section 1 of the Pearson A-Level Maths Applied Maths Year 2 textbook. I'm going to start off this teaching video by going through some important notation. Let's have a look at these important notation. The first one represents the sample space. The next one is the empty set. The probability of the empty set is equal to 0. This one over here represents the intersection and overlap. This one represents union or combine. Suppose A is an event. A dash represents not A. Probability of not A is equal to 1 minus probability of A. Two events, A and B, are independent if probability A intersect B is equal to probability A multiplied by probability B. Two events A and B are mutually exclusive if probability A intersect B is equal to 0. Here is the diagram modeling two mutually exclusive events. As you can see, there is no intersection between the events A and B because probability A intersect B is equal to 0. Okay guys, right now I've got 5 Venn diagrams up on the board. For each of these Venn diagrams, I'm going to be shading in a specific area representing the given set notation. So over here we've got A union B, A intersect B, not A intersect B, not A union B. This Venn diagram will be used to shade in the fourth Venn diagram and the fifth Venn diagram. Let's start off with the first Venn diagram. So we have A union B, which is the same as A or B, which is the same as A combined B. So we need to shade in the whole of A and the whole of B. The second one, we have A intersect B, which is the same as A and B, which is the same as A overlap B. So we need to shade in A overlap B, which is this particular area. The third one, we have A dash, which is the same as not A, which is the same as everything outside of A. So we need to shade in everything outside of A. The fourth Venn diagram, we have not A intersect B, and the fifth Venn diagram we have not A union B. If you find it hard to actually visualize the shading, I'm going to actually show you a useful method that you can use. This method is called the hashtag method. So I'll use this Venn diagram to show you what the shading for the fourth and the fifth Venn diagram will look like. So we have not A and we have B, not A and we have B. So for the not A, I'm going to shade it using vertical lines. So not A is everything outside of A, shade it using vertical lines. For the B, I'm going to shade it using horizontal lines. So the whole of B using horizontal lines. Let's have a look at this set notation. We have a not A intersect B. So that is the same as not A overlap B. So what is the overlap? Well, the overlap is the hashtag area, which is this part over here. So I can shade it here. And that there represents B only. So not A intersect B is the same as saying B only. This one over here, not A union B, that's the same as not A combine B. So you're looking at the whole shading. So you shade in everything apart from this part here, which is A only. And there you have it. That represents not A union B. So this method over here is brilliant. It's called the hashtag method. Let's move on to a Venn diagram with 3 events. So I've got 7 Venn diagrams up on the board. For each of these Venn diagrams, I'm going to be shading in a specific area representing the given set notation. This Venn diagram will be used to help us shade in the 6th Venn diagram, and this Venn diagram will be used to help us shade in the 7th Venn diagram. Let's start off with the first Venn diagram. We have A intersect B intersect C, which is the same as A overlap B overlap C. So the required shading is the intersection of all three events, which is over here. The second Venn diagram, we have not A intersect B intersect C, which is the same as not A overlap B overlap C. So the required shading is everything outside the intersection of all three events. So we need to shade in everything apart from this part over here. The third Venn diagram, we have A union B union C, which is the same as A or B or C, which is the same as A combine B combine C. So we need to shade in the whole of A, the whole of B, and the whole of C. The fourth Venn diagram, we have A intersect B intersect not C. This is the same as A and B only. So A and B only is this part over here. The fifth Venn diagram, we have A intersect not B intersect not C. This is the same as A only. So A only is this shading over here. Let's have a look at the 6th and the 7th Venn diagram, which is a bit more challenging to visualize. So we're going to use the hashtag method. For the 6th Venn diagram, we have A intersect C union B, which is the same as A intersect C combine B. I'm going to use this Venn diagram to shade in the area representing this set notation. Firstly, A intersect C, I'm going to shade it in using vertical lines. So that will be this part over here. Then B, I'm going to shade it in using horizontal lines. So the whole of B. So for this set notation, we need to look at the whole area. So this whole area, I'll shade it here. There you have it. Let's move on to the 7th Venn diagram. We have not A union not C intersect B. Now, we can actually rewrite this set notation using De Morgan's law, which states that not A intersect B is the same as not A union not B. So if you apply the not to the events A and B, that will reverse the intersection into union. So not A union not C is the same as not A intersect C. So we have not A intersect C intersect B. So if I was to shade in this set notation, that is the same as shading in this set notation. Let's have a look at this Venn diagram to help us shade in this set notation. Firstly, not A intersect C, I'm going to shade it using vertical lines. So everything outside the intersection of A and C using vertical lines. Then B, I'm going to shade it in using horizontal lines. So the whole of B using horizontal lines. This set notation over here is just the hashtag area. So the hashtag area will be this part here, this part over here, and this part over here. Okay, so we have this part, and this part over here. So technically, the whole of B, apart from the intersection of all three events, represents this particular set notation. Let's have a look at example 1 and example 2. Example number 1, shade part A intersect B union C on this Venn diagram. Part B, not A union not B intersect C on this Venn diagram. Let's start off with part A. Firstly, A intersect B, I'm going to shade it using vertical lines on this Venn diagram. So the intersection of A and B is this part over here. The C, I'm going to shade it using horizontal lines on this Venn diagram. So the whole of C using horizontal lines. Now, A intersect B union C represents the whole shading. So we have this part shaded. I'm going to shade it on this Venn diagram. And there you have it. Let's move on to part B. We have not A union not B intersect C. Firstly, we can rewrite this using De Morgan's law. So not A union not B is the same as not A intersect B. So we have not A intersect B intersect C. The not A intersect B, I'm going to shade it using vertical lines. So everything outside the intersection of A and B. This here is the intersection of A and B. We're going to shade everything outside this using vertical lines. Right, now the C, I'm going to shade it using horizontal lines. So the whole of C. Now, not A intersect B intersect C represents the hashtag area. So the hashtag area over here is the whole of C apart from the intersection of all three events, which is over here. So I can shade it there, the whole of C apart from the intersection of all three events. So there you have it. Let's have a look at example number 2. A and B are two events. Probability A is equal to 0.5, probability B is equal to 0.2, and probability A intersect B is equal to 0.1. Find part A, probability A union B, part B, probability not B, part C, probability A intersect not B, and part D, probability A union not B. Before we work out these probabilities, we should set up a Venn diagram. So I'm going to draw a Venn diagram. This is my sample space. I label it using the correct notation for the sample space. I've got the two events, A and B. Now, when drawing a Venn diagram, you should make sure that you label the intersection first. So the intersections over here, the probability A intersect B is equal to 0.1, so we can put 0.1 over here. Now the probability of A is 0.5, the 0.1 is used up, so this part over here has to be 0.5 take away 0.1, which is 0.4. The probability of B, ladies and gents, is 0.2, 0.1 is used up, this part has to be 0.2 take away 0.1, which is 0.1. So 0.4 plus 0.1 is 0.5, plus 0.1 is 0.6. The outside will be 1 take away 0.6, which is 0.4. So that is my complete Venn diagram. Let's have a look at part A. Probability A union B is just 0.4 plus 0.1 plus 0.1, which is 0.6. Probability not B is everything outside of the event B. So we have 0.4 plus 0.4, which is 0.8. Part C, probability A intersect not B is the same as probability A only. So that will be this part here, 0.4. Probability A union not B. So that is the whole of A. Okay, so we have 0.4 plus 0.1 combined with the whole of not B. So everything outside of B. So we have the 0.4, this one, which we've already taken into account. And then we also have the 0.4. So I must add on the 0.4. So 0.4 plus 0.1 is 0.5. And then 0.5 plus 0.4 is 0.9. So that there, ladies and gents, completes example number 2. The key was to draw your Venn diagram, and from the Venn diagram, it is simple to work out the probabilities. Here is an exam style question. A, B, and C are three events with probability A equals 0.25, probability B equals 0.4, probability C equals 0.45, and probability A intersect B intersect C equals 0.1. Given that A and B are independent, okay, so that means that probability A intersect B is equal to probability A multiplied by probability B. B and C are independent, which means that probability B intersect C is equal to probability B multiplied by probability C. And A intersect and not B intersect C is equal to the empty set. So this set notation can be rewritten as A intersect C intersect not B, which is equal to the empty set. But this here is the same as writing A and C only, which is equal to the empty set. So the probability of A and C only has to equal 0, because we know that the probability of the empty set is 0 by definition. Part A, draw a Venn diagram to illustrate the probabilities. So here is my Venn diagram. So I've got the event A, B and C, and the rectangle I must label it with the notation for the sample space. Okay, so we start at the intersection of all three events. We know that probability A intersect B intersect C is equal to 0.1. So this part here is 0.1. Now, probability A intersect B is given by probability A multiplied by probability B. So we can work out what this intersection of A and B would be. So we take probability A, which is 0.25, and we multiply by probability B, which is 0.4. So if I multiply these two together, I get 0.1. So this whole intersection has to be 0.1. But 0.1 is already used up over here, so this part has to be 0. Okay, now probability B intersect C can be calculated by probability B multiplied by probability C. So 0.4 multiplied by 0.45, which is going to be 0.18. So we've got 0.1 used up. This part has to be 0.18 take away 0.1, which will be 0.08. Probability A and C only is 0, so that part there I can label it as 0. Probability A is equal to 0.25. To work out this portion, I can do 0.25 take away 0.1, which is 0.15. Probability of B is equal to 0.4. So to work out this portion, I must do 0.4 take away 0.08 take away 0.1. So this part over here must be 0.22. The probability of C is 0.45. To work out this portion, I must do 0.45 take away 0.08 take away 0.1. So this part here is 0.27. The outside portion, you then do a 1 take away the sum of all the other probabilities. So the outside portion will be 0.18. And that there is my complete Venn diagram. Okay, let's move on to part B. Find part 1, probability not A intersect, not B union C. Firstly, I'm going to shade in not A using vertical lines, so that's everything outside of A. Then I'm going to shade in the whole of not B, so that's everything outside of B using horizontal lines. Combined with union C. So I'm going to shade in C using horizontal lines. So the whole of C. So the intersection of these two events is just the hashtag area. So the hashtag area is this part over here, which is 0.08. Plus this part over here, which is 0.27, plus this part over here, which is 0.18. So we have 0.08 plus 0.27 plus 0.18 equal 0.53. Okay, let's move on to part 2. So we want to work out probability A union B intersect with C. Firstly, A union B, I'm going to shade it using vertical lines. So the whole of A and the whole of B. The C, I'm going to shade it using horizontal line. So the whole of C using horizontal lines. Probability A union B intersect C is just the hashtag area. So the hashtag area is this part, and this part. So we would add up this part, which is 0, plus this part over here, which is 0.1, plus this part over here, which is 0.08. So this gives us 0.18. Let's move on to part C. State with reasons whether events not A and C are independent. Firstly, let's work out probability not A. So probability not A is given by 1 minus probability A. So that would be 1 minus 0.25, which is 0.75. Then we have probability C, which is 0.45. We can calculate probability not A multiplied by probability C, which will be 0.75 multiplied by 0.45. So if we multiply these two together, we get 0.3375. Now we need to calculate probability not A intersect C. So here is the Venn diagram that I'm going to be using to shade in the event not A intersect C. So not A, I'm going to shade it in using vertical lines, so that's everything outside of A. And then we have C, which I'm going to shade using horizontal lines. So the whole of C, using horizontal lines. So we have that not A intersect C is just the hashtag area. So the hashtag area, ladies and gents, will be this part over here, which represents 0.08, plus this part over here, which represents 0.27. This is equal to 0.35. Now we have that probability not A intersect C is not equal to 0.3375, which is precisely probability not A multiplied by probability C. So because probability not A intersect C is not equal to probability not A multiplied by probability C, we can state that not A and C are not independent events. Because remember, for two events to be independent, we must have that, for example, A and B to be independent, probability A intersect B must equal probability A times probability B. So that there completes the exam style question. If you found this video useful, please don't forget to subscribe.